So, in the first class, we already have a brief discussion about the scalability for the routing protocol. And right now, let us continue to address the scalability for the routing protocol, and so that we have the other protocols. Well, so up to now, we don't know, even we have link state and distance vector. They are ideal routing protocol. And to make them scalable, so we should consider we cannot have all destination in the routing table. So we should have the distance vector. So it says, summarize, we should have the distance vector. Even we don't think distance vector let us have the robustness. And actually, we need to have the change, you see. So dV here, that says we cannot have a lot. So yeah, we have a dV, but it doesn't mean all us have a dV. So possibly we expect to have LS. So is it possible to still have a LS, but we want to have a dV as well? Right? And also we should have autonomy. And autonomy allows us to have our own control over the area you want to control. And I already have the key terms, swamp and autonomy. Well, so actually we should have the scalable routing. To have the scalable routing, the first thing should be we should have the autonomy. Okay. So the issue for us actually we should have the scalable routing algorithm. And to have the scalable routing algorithm, then we should have the autonomy, the concept of autonomy. And the concept of autonomy says we should have the autonomous system. So here we have AS. So AS also known as the domain. Well, if we have a domain, first of all, we can have the intra-AS or intra-domain. That says we have a domain within the domain. That says within the domain, so we have the intra-AS or intra-domain routing protocol. Well, routing within the same domain, within the same AS. Then, same AS, how about the scale? The scale can be small. Alright, if the scale can be small, is it possible to have the implementation of the link state routing algorithm? The answer should be yes. So, we consider the first category, intra-AS. So, all routers are within the same AS, and we should have the same intra-domain protocol. And of course, if we don't have the same AS, we want to have the routing among the AS, then we have the different routing protocol. But right now, the second item says, if I have a different domain, should I run the same routing protocol? Perhaps no. All right, perhaps no. So if we have a domain, each domain can its own control to choose the suitable routing protocol. For example, right now I have a small scale domain, so of course link state should be okay. However, if I have a large enough domain, then we won't have some specific link state routing algorithm. Maybe you have the different consideration, but normally we won't have the different size, or the difference won't be really large. So we expect to have the comparable scale rather than the really different scale size. And of course, because of for the domain, then we have for the gateway. The gateway router says, well, this one can have the connection with the other domains. So we have the gateway router. And normally you have the idea of gateway. And right now for the consideration, we have a gateway. So in the past about the routing, we don't mention gateway, but for this one, for the realistic consideration, we have the concept naturally to have the gateway. And so that we have the gateway router. Well, initially we have intra. And actually we already have inter. Inter says, how about Taiwan? And how about, for example, US? And Taiwan and US, we have two domains. And we want to have the maybe interaction between Taiwan and the US, then it's inter AS. And so that the routing among AS. All right. So if we want to do that one, then we need to have the rows of the gateways. And the gateway will perform the function if we want to have in fact, exchange the information. For DV, we should exchange the information. Same for the current interdomain, we need to exchange the information. Well, if we have AS, we should have the interconnected AS. All right, we expect them can be interconnected. And for example, here we have AS1, 2, and 3. So, routing within the domain, we have intra. Currently, you see, intra. Let me emphasize within the domain intra, intra, and intra. Maybe that they are not the same, but at least we have for the same category intra-AS routing algorithms. And here, inter, here. In fact, you can think, okay, we have a single node. Single node, and single node. So, inter. All right, so we can make OLS to be a point. And routing for all the points or for all the nodes by treating AS as a node. Then we can have the inter-AS routing. All right, so it doesn't mean, okay, AS3 and AS1, we have one intro, one inter. And AS1 and AS2, we have a different inter-AS routing. No, in fact, we have inter-AS for all the three autonomous systems jointly. So that's why I have 3 points to denote the 3 AS. And so that you have the inter-AS routing. Well, so here we consider inter-AS routing forwarding table configured by the intra and inter-AS routing jointly. If we want to have the routing, maybe from the current node in AS, for example, AS1, but the destination, it should be a node in AS3. So of course, we should have intra and inter-AS routing algorithm. So forwarding table will configured by the 2 types of routing algorithms. Well, here we have intra and later we have inter. You see? Intra and inter jointly to configure the forwarding table for a node. All right, so Here, of course, we expect to have the routing from some node in AS1, and then later we will have a router in the other AS. And then here we pose a question. Router should forward packet to gateway routing in AS1. That's correct. But which one? So the current one says if we want to have this, then it says if we have AS3 and AS2, if we know the two AS and we have the destination in AS2, then we should choose the gateway close AS2 rather than gateway close AS3. So of course, if we have the concept, then we will choose that gateway. All right, and of course, we have the inter-domain routing. And we'll learn which node, which router will reach AS2, and which router will reach AS3. And so that we know the information. And then we can have the proper router that says proper gateway. All right, so how to choose that one? We should know the gateway and set the gateway for sure. And let us get back to the intra-AS routing. And we want to study some of the examples. Actually, if we have the intra-AS routing protocol, you can look up by checking the RFCs. We can have the first one, Routing Information Protocol, RIP. The current RIP is not the same as the usual RIP. All right, it's Routing Information Protocol. And we have EIGRP, Enhanced Interior Gateway Routing Protocol. And the next one is OSPF. Well, we focus on OSPF, but we didn't know, yes, for the intra-AS, for different domains, they can choose different routing protocol. And in fact, we can have OSPF, we can have RIP, we can have EIGRP. And here, you can check them quickly. RIP, it's classic DB. Why classic DB for the intra-domain? We don't know if we still have a large enough size. Then we should have a DB pathway. And the OSPF is link state. So even for the intra-domain, we still have two possible choices, DB and link state. So it's natural. At least we should provide the possible choices, DB and link state. And the second one, DB again. So let me highlight, we have these. All right, so even for the intra-domain, we have the two choices. And DB and link state. And furthermore, for IP, in the past we use it frequently, but here no longer widely used. No longer widely used, so it's an old version, so no longer widely used. And for EIGRP, formally it should be the Cisco proprietary for a few decades, and then become open. And for OSPF link state, the current one is the link state. And we have another one we call ISIS. It's based on the OSPF as well, right? So we have three choices, RIP, EIGRP, OSPF. Some of them are DB based, some of them are link state based. And we talk about OSPF in the following discussion. Of course, OSPF is an open one. Different from EIGRP initially, it's an open. So that's why we have the term open shortest path first for the current routing protocol, OSPF. Well, it's available to the public. Therefore, we have the open routing protocol. And compared to RIP, we have the classic DV, and currently OSPF is a classic link state routing protocol. And so that we need to have flooding. Right? Why we should have flooding? Because link state need to know the entire topology of the network. So we need to have the link state advertisement. Well, in the following discussion, it's really important to have information distribution by using advertisement. Let me make sure and emphasize advertisement. So even it's routing, but later you may think, okay, why we always mention advertisement? Because we need to allow the node to have the information. The information of link cost, the information of distance vector. So of course we need to have advertisement or information update or something else. And to have advertisement, you see, directly over IP rather than using TCP, UDP. Well, currently it's a network layer, so we don't know. Possibly we pass on network layer as well. All right. Why? Network layer as well? Because it's easy to enable. I mean, easy to fast, or maybe it doesn't mean easy. We have the fast solution. The network layer, so we have IP. And even with the IP, you can think routing protocol a bit above IP layer, even within the same network layer. So above or over IP. So over IP rather than using TCP or UDP. So advertisement, however, for OSPF, just the cost. Actually, the cost can pass on bandwidth delay. So you can have your own definition to have the link cost. And link cost can be have the combination of bandwidth and delay as well. So we can have multiple choices. We can have a combination of the choices here. And of course, because of link state, so we should have a full topology. And because of a link state, of course, we use Dijkstra algorithm. Well, up to now, we have the routing algorithm. And maybe we have a different issue, security. Well, in the past, we all think we don't have the security issue for network. But for the real situation, we should consider security. And for security, how to avoid the security issues, we should have message authentication. Message authentication, all right? And so that we can prevent the malicious intrusion by sending the maybe some message try to compromise the network. Maybe not the network, at least try to avoid to have the proper function of routing. So those kind of messages possibly sent to the network, and so that avoid the possible function of the routing algorithm. So we prevent the malicious intrusion. Well, we use the term intrusion, but we try to have the different messages, not the normal message to interrupt the function of routing protocol, OSPF. So we have the security consideration. We just mentioned we have the issue of security, and we don't have the further description because we already know we have the message authentication. If we have the valid message, then we allow the valid message to join the function of routing. If no, then those messages will be dropped. So we have the message authentication. Well, so we don't know OSPF based on the dashboard routing algorithm. Of course, we have the flexibility to make OSPF realistic. And make it realistic, we have the second direction. We can have the hierarchical OSPF. Why we want to have a hierarchical? Well, if we have a domain, the domain can be reorganized and so that we can have the hierarchy or the autonomy of the domain. And how to have the hierarchy or the autonomy of the domain? We can have, for example, multi-levels. And here we have a multi-level, level 1 and level 2. And so that we have the hierarchy. With the two hierarchies, then we have the hierarchical OSPF. You see, I mentioned we have two levels. Therefore, we have the two-level hierarchy for the OSPF. And we can have a smaller area, 1, 2, 3. And we can have the backbone, same. We have the smaller area. So, why we want to have this kind of a solution? Because we still expect to have a link-state routing algorithm. So link-state routing algorithm will be suitable for the smaller size. If we have the concept of a hierarchy, then we can split the domain to the smaller domain as well. For example, the current area 1, area 2, and area 3. Right? So we can have the even smaller domain within the same domain. So that's why we expect to have this kind of solution, hierarchical OSPF. Well, for the hierarchical one, because of that reason or that background, we will have a local area, then we have a backbone. Specifically, we have a backbone. All right. Well, if so, then same, link-state. So link-state because of OSPF. And link-state advertisement flooding only in area or backbone. If we have the smaller area, if we have the current backbone, how about the size? The size becomes smaller. So it will be feasible using the link-state. Alright, so link-state advertisement flooding only in area and backbone. And HNode has the detailed area topology. Right? And knows the direction to reach other destinations. So actually, we have the information within the area, and the area to the other area, then we have the the necessary information based on the OSPF node. Alright, so we should have the hierarchy, but for the other node, try to pass on OSPF to know the existence of the other node. And so that we still can pass on the hierarchy or the two level using the hierarchical OSPF. And therefore, same, we have the border. Here we call border. Area border router rather than gateway. Alright, we have a new term. If you don't like it, yes, we have the gateway. Yeah, gateway is still okay for the current discussion, but we have the new term, it's a border. Why it's a border? Because the current border going to area 1, border going to area 2, border going to area 3. So we have area border routers. Going to the area and going to the domain, then to a different area. So we have an area border router. It can summarize some information within the area. So summarize here. Even we have the hierarchical links there, but we have the domain. But the current domain is area to domain, and border to the gateway. So we still have the concept. So it's okay. Well, so local router actually we will have LS flooding advertisement and compare within this and forward within this unless we want to go to the destination in a different area. Then we will forward to the border area border router. Well, the current one actually is a domain. And this domain will go to the other AS as well. So we have a route. That route serving as the boundary router. Okay, we have the boundary router. And the boundary go to the different AS or come to the current AS. All right. And of course, we have a router within the backbone, so we call it's the backbone routers. Same, it's a router, but within the area code backbone. All right, so this is the OSPF. OSPF actually emphasizes we based on the links there. Try to have the links there. Of course, the size should be tailored specifically. If yes, okay, we have the current size, no problem. We still can have the flat OSPF. If, for example, we have 2 classroom here and classroom in maybe 311, and in 311 the size is small, and current one is large. So if we want to have the different consideration, we can borrow some concept from the autonomy to have the hierarchical version. So this is a current discussion about intra-domain by using OSPF. I already have 1 minute to think about this version. Okay, you can feel free to discuss with your neighbors. All right, so I think maybe no problem, and then we keep going to the next one. Next one actually is an inter-domain routing protocol, which is BGP. BGP says the border gateway protocol. Well, you see, we have autonomy, we have the domain, but this time we use border gateway protocol, but at least we have a gateway. All right, so maybe we have the mix, or maybe mixed terms to have the BGP, border gateway. Well, we have a term, de facto. De facto says for the industry purpose, for the company purpose. So this is the de facto inter-domain routing protocol. So that says it's a practical version. and the practical version for the industry, for the company. And with the BGP, then it can serve as a glue. You should know the meaning of a glue, right? 胶，一个胶。A glue so that it can hold the internet together. All right. Why we use the term glue? Because it's the inter-domain. So of course we need to make them interconnected. So of course we expect a function of a BGP. And BGP allows subnet to advertise its existence. I don't know, for routing, normally we should have the information. And we also need to take care of the information advertisement. So yes, it's true. For subnet, we should let the other node know, yes, here I am. Look at this. Here I am, it's important. Or otherwise, oh, okay, no one knows me, I'm here. So they cannot reach me. Therefore, we should have the advertisement. So this one is important, advertisement. All right. And later, in fact, you will feel, yes, all I have for the information exchange talking about the advertisement. So I don't know, I'm here. Here is who I can reach and the others. So you can let them know I'm here. Also, you can let them know the past information, which node I can achieve, or which node I can reach. And so that you can trust me if you want to ask me to relay. And for BGP, we have two means, two ways. The first one is E. eBGP says external, and I says internal. 外面跟内部. So we have eBGP and iBGP. And E so obtain subnet reachability information from neighboring AS. You see, E allowed to have the inter-domain or inter-AS information. We have the external one, so we have eBGP. And iBGP says we know the information and propagate reachability information to the internal routers. So within the AS. And so that we can determine the possible route. And of course, for the BGP, we need to use two of the approaches or two means. Well, talking about eBGP and iBGP here, we have the color. You see, where we have eBGP. It's an inter-AS. Where we have iBGP within the AS. So we have a gateway router. Gateway, so we have the previously I didn't have a single node. In fact, for a domain or for the AS, actually we have the different gateways. And even for the different gateway, if we want to treat, we have the inter-domain. You can treat. We have a single node for the AS, but actually we should have multiple gateways because we have the multiple AS. So of course we have multiple gateways. Well, for BGP, we have the fundamental description. So first of all, we already have in fact, we try to have the message exchange or try to have the advertisement. Then we need to have the BGP section. Two BGP router peer exchange, you see, exchange BGP messaging over here using TCP. And we have the term semi-permanent TCP connection. Maybe you can look up, I just mentioned we use a TCP connection. Previously, we have the IP directed to have advertisement because we can reach it quickly, but the current one, no, we based on TCP connection. And so that we can have the message exchange. And message exchange to advertisement for path to different destination using network prefix. So here we have the network prefix. All right, and network prefix so that it's a path, and so that it's a path vector. So previously we have a distance vector to a node. But right now we have a network prefix. Network prefix is a path, and here we have a path vector for BGP. Well, they emphasize path vector. And for example, later we have AF3 here, AF3 here on the right-hand side. Even previously we have AF3 on the left-hand side, but currently we have AF3 on the right-hand side, and we have AF3 gateway 3A. 3A advertised path. Okay, currently I'm AF3. I can reach X. Here we have X. So through AS number 3 to X, and we want to let the other S know, so send the information to AS2. That says to have the advertisement. And so that says AS3, the current gateway, you should promise you can reach X. If you cannot reach it, sorry, you cannot have this kind of advertisement. So the current BGP, of course, should guarantee if we have the network prefix advertisement by some AS gateway node, it should promise, yes, I can reach X. So for AS2, we should trust it. If we should trust it, then you have an idea. Okay, how about the intrusion? Okay, trust me, but I cannot do that for you. It's okay as well, so it's a tax. But currently we think, yes, this is the requirement, you should trust it. Well, so we will have a section, that section using TCP, that TCP can have the advertisement. All right, and actually we have the advertised route. The route should be prefix plus attributes. The attribute, because we have the different way to process, so we call it attributes. Prefix, I think up now it's okay, it's network prefix. And the attribute says, okay, only the path. Yes, we have a path. So we have the choices AF path. Then we have a list going through different AS, and then we can reach some place. So this is attribute AS path. And next hop, in fact, we have the specific node, so it's the next hop. So we can have the network prefix using the AS, but we still have the specific node or hop. And furthermore, we have the really important one, it's the policy. Why policy? Think about someone like, it doesn't mean as a word. Trump. Yeah, it's Trump. Trump tried to have the good policy for economics. So try to use a policy, right? And a policy, so the other countries should follow that policy. And likewise for routing, we have a policy as well. Because of domain, so the domain should have its own policy. So policy is a possible consideration. Again, I emphasize, like the economics by the US by the US President Trump. We have a policy. And so that we have a policy-based routing. All right, so you have your own reason. If we talk about policy, how to form the policy. For the US, they should have their own policy. For Taiwan, we can have our own policy. So talking about the policy, then of course we should care about the revenue or benefit. Sure, normally we should care about the revenue or benefit. But sometimes, is it reasonable? Sometimes no, right? Sometimes no. So we should accept something if we take some policy. Well, I just want to let you know, talking about BGP, we have a really special consideration policy. And also, when we talk about OSPF, should we have any discussion about policy? No, right? No policy there. But why I mention policy here? Because we have the inter-AS, inter-domain. So we have the possible consideration of a policy. Well, I make it different. In the previous discussion, yes, no policy. Because we have a single domain. A single domain, so of course we don't have the necessary consideration of a policy. However, we have a multiple domain or multiple AS, so we should have a policy. Well, here we have advertisement and also need to pass on the important policy. Important policy to accept your path, your suggestion, or you don't want to accept their suggestion, so that you decline the path. Well, if you want to decline, maybe we call policy. But maybe for the other AS, they say, okay, why this reason? No reason. It doesn't mean no reason, but based on a policy. And the policy can have the way to have the advertisement as well. For example, same for the economy. If we want to earn money, how about earn money from a small country? And how about earn money from a large country? After the consideration of a revenue or maybe some benefit, then you should have the consideration to make a deal with a large country normally. But sometimes you don't have the consideration. Try to reverse the idea, it's possible. So it's a policy. Well, here I want to emphasize up to now, routing. Yes, it's routing. But based on some information, then we will have a routing. What kind of information? Network prefix, reachability. So we should heavily rely on the function advertisement. Well, up to now, I tried to emphasize for BGP, we emphasize the path advertisement. Then naturally you can have the routing, the function of routing. So it doesn't mean we don't talk about the routing. Yes, we talk about routing, but routing based on the path advertisement. So it's really important to let you know we have the function of path advertisement in BGP. All right. So we have the way if we reach X and that AS to no, and as to no, then you can see gateway router to C receive it, all right, and which way? Via eBGP, right? I emphasize via eBGP. I emphasize via eBGP, and so that we have the reachability information. It's network prefix. All right. And based on this one, AS2 policy, I circle policy again. Yes, we accept. So based on AS2 policy, we accept. And then we will propagate the information through IBGP. So within the AS, it's I. From the other AS, it's E. So E and I BGP, you should have the proper way to know. All right, so through IBGP, then we can propagate to the other nodes. And likewise, you can have the network prefix. So advertisement, even for AS2, we should have the advertisement for AS3. And so that we can have the reachability for the entire network. And then we have a network prefix AS2, AS3 to X to AS1. And likewise from EBGP to reach 1C. And 1C then we can learn. But for 1C possibly, we can have a different way to reach. Maybe you have a reason why, but yes, it's true. A different way from this, a different way from this. So here we have a story. 1C learn multiple paths. AS1 gateway, 1C can learn this one from 2A, or maybe from 3A. Of course, because of a policy, which one will be accepted? Then based on the policy of AS1, or maybe based on some criteria, then AS1 can have the determination. Here we use a simple term. Based on policy, AS1 gateway 1C choose still AS3 to X. Why? Currently, maybe the policy says the shortest network prefix. All right. Or maybe sometimes, no, I don't want to use AS3. I want to use AS2. Same. Based on policy, we can have the determination. For AS1 and AS1, then we will allow the other node via IBGP. All right. So talking about the routing, but right now we care about advertisement. Maybe initially you think, okay, why you don't want to let me know the routing information? Actually, I should let you know, yes, we have the routing information carried, but we should allow the other node, yes, I can do that for you. And then once we have all the information, then we reach the function of routing. So the role for BGP actually, many that know the advertisement. All right, so nothing wrong. It's correct, but we have a new term, advertisement. All right. So let me close it. Within the class, we already have the extended description for intra-domain routing, OSPF. And after that one, we have the special one, inter-domain BGP. And BGP, we have eBGP and iBGP. Among domains or within the domain. So we have eBGP and iBGP. All right. And later we will already have the distinguished eBGP and iBGP using a thin pair shell this Wednesday. All right, before you go, let me make sure any questions? If no, see you this Wednesday. Bye-bye.